Hello everybody. Welcome to another event in the ICP Chain Fusion Educate series. Today we are welcomed by two amazing speakers, one from WeiChain, one for CCP, but more on that later. Now, first of all, we are joined by Tito from WeiChain, who will be telling us something about Universal Multichain Bridge powered by Threshold, ECDSA. So without further ado, Tito, feel free to share the screen, start a session, and anybody else, if you have any comments or questions, feel free to pop them in the chat.
Yeah, perfect. Thanks you for having me. It's a real pleasure, and yeah, I will be happy to share some of our insights regarding ICP and cross-chain communication and stuffs that we've been working on recently. If you have any questions, I'll check them at the end of the presentation. So yeah, I think that we can start. So before I start, a few words about me. I'm a blockchain researcher and developer. For the last 6-7 years, my team and I are working on different chains, smart contracts, and protocols. One of the famous one was JellySwap. It was a cross-chain atomic swap protocol, one of the first cross-chain atomic swap protocols based on HTLCs back in the days. But yeah, I think that nowadays ICP is one of the best chains for multi-chain communication. And today I will speak about the universal multi-chain bridge that we can develop on ICP, powered by tECDSA. So first of all, what is the threshold ECDSA signature in ICP? It is also known as chain key signatures. You can find it in the documentation. The idea is that we have a private key that exists on the blockchain, but all the nodes have only small share of this key and no one have full access over this private key. On request, some of the canisters can request a signature for this particular secret key, but without ever exposing or knowing the private key itself, only the signature from it. Yeah, the ECDSA, the chain key ECDSA is also responsible for distributing the keys, for generating the keys, and periodically sharing. Another thing that that we can see at the moment is some applications of these threshold signatures. I know that all of you are aware of cKBTC, which is a Bitcoin backed and built on top of the chain key signature logic. We also have the ckETH. Now we have the CK USDT, if I'm not mistaken. So many more are coming. All of these integrations are built on top of this building block, the chain key cryptography on top of ICP. And yeah, basically there are some other chains that are coming as far as I know. And everything looks good so far, but there are some limitations. And we are trying to overcome these limitations and make the threshold signatures more universal and use them for even for chains that are slightly different. But I'll get into that on the next slides. So first of all, there are some missing stuffs. For example, there is no built-in option to derive ECDSA signatures. These ECDSA signatures are, for example, used in Solana, Cardano, and some other chains. There are some other chains that are even more exotic, I could say, and they have different signature schemes. For example, we have end-through encrypt. This is used in the quantum resistor ledger, which is based on lattice cryptography. It is not a super famous blockchain, but I think that in the future we'll have more chains that are using different schemes. I just mentioned it to show you that there are different schemes and they will become more and more. there is missing built-in option for built-in option to derive a signature for the winter nits. It is another scheme which was used in IOTA back in the days. At the moment, I think that they're switched to ECDSA, but as I said, I think that it will be more schemes used in the blockchains that are arising. And we don't have a built-in option for ring signature, which is used for Monero. They are even more specific, and of course, it is related to their privacy-heavy ideas. So there are two possible solutions, in my opinion, like different ideologies. One of them is the implement all possible signature schemes on top of the ICP base layer, on the blockchain layer. In my opinion, this is slow, it is expensive, and it is a never-ending task. At the moment, we have the ECDSA signature support because it's the most famous one. There is some work in progress about the ECDSA. There are some schemes supported, but I mean, there are tens of different signature schemes that are used at the moment, and they will become even more. And you can imagine that every time when you want to integrate some chain that is not supported, this will require some heavy development on the blockchain layer. Then it just have to be audited and all that stuff, and it will definitely take months. And the work will become more and more. So I don't think that this is reliable. Like, it is good if we can have it, but I don't think that this solution is very viable. The other option that I think is kind of workaround, but it is more universal and can work now and in the future for more and more chains, is using the existing tECDSA signature scheme, and on top of that, use some smart contracts on the other chains that are just verifying this signature. So that way, we don't have to support all the cryptography schemes for the different chains. We will just produce an ECDSA signature with some payload. Then it will be verified on the destination chain in their smart contracts. And if everything is fine, we can move value from the destination chain and to the destination chain. The key idea is very simple. I think I explained it, but if we go into more details, the idea is that we're creating a signature on the canister side, and then in the smart contract on the destination chain, we are verifying this signature. I've gave some examples here. So, for example, for ETH, we have the ECRecover function, which is doing exactly that. It is receiving a signature, and it is validating if the signature is provided from the right private key by verifying if the public key is matching. This is for ETH. We have similar function for Solana, which is called SecP256K1 recover. It is equivalent of ECRecover. We have object seek on BTC, even though BTC is super simplified, having in mind the smart contract functionalities, it still have some opcodes and can verify such kind of signatures. So this is example only for ETH, Solana, and Bitcoin, but it is the same for many other chains with different signatures, but most of them have this kind of cryptography function on their smart contract level, where they can verify if the signature is signed with the right private key, and they can verify it by checking if the public key is matching. So our whole idea is based on that. We're assuming that most of the chains will have this ECRecover-like function, and we'll be able to have only a single canister that is providing signature with different payloads. We're calling them vouchers. And then we can verify these signatures on the different chains. And if everything is correct, we can unlock the funds that are inside these smart contracts. the main technologies that we're using into our bridge are HTTPS outcalls. We're checking the events that are coming from the other chain, if it's a deposit or there's some burn of tokens or whatever. We're just fetching this event, and based on that, we're doing some actions on top of the ICP network within the canister. We are using a chain key cryptography in order to generate this signature and to sign the paywall using the tECDSA, the threshold signature, which is super secure and, in my opinion, piece of art, having in mind that I haven't seen other chain, only ICP supporting this at the moment, as from what I saw. We have the ICP canisters, which are also a building block, the smart contracts that are keeping the business logic. And we have smart contracts on the other chains where they are verifying the signatures, and they are also basically holding the deposits that are done. If we look at this simple scheme diagram, you can see what the workflow is. For example, we have some user which has some Solana tokens and want to have some Solana tokens on top of ICP, and the workflow is the following. First, the user is depositing some Solana tokens to this Solana contract. We're calling it the treasury contract. When the deposit is done, a blockchain event is emitted, and we have a scrapper in the ICP canister, which is using HTTPS outcalls, scrapping for transaction events, and if a transaction is detected, then the minter is basically minting a new asset, which we are calling in our case with Solana GSO. And once the asset is minted, it is sent to the address that has deposited originally the Solana token. And we can understand what is their ICP address, because inside this deposit transaction, there is some metadata, and the user is also passing their Solana, their ICP address. In the other side, when we have a withdrawal, we have the other direction. We have the function in the other direction. So the user is giving approval of their GSO tokens to the ledger. This is another canister. The user is burning their GSO tokens. Then the ledger is executing this burn operation and generates a coupon by signing this paywall with the threshold tECDSA signature. And once the coupon is generated, then the user can use this coupon to broadcast a transaction to the Solana treasury program and to withdraw. And if the signature is correct and everything is fine, this is verified inside the Solana treasury program, then the funds are unlocked and the user can receive their original Solana tokens back. So you can see how simple is that and robust. And basically it works for Solana, but it could work for other chains as well with very small modifications. If we want to get into more details, I'll go through this fast. It is basically the same picture from the other slide, but with more details. So we have some simple web UI. We're connecting our Phantom wallet. Then we select the amount of SOL that we want to convert into GSOL. We click Mint, and our SOL tokens are walked into the Solana treasury program. Once this is done, we have some RPC providers here, which the GSO minter, the canister, is calling. It is fetching the events all the time. It is a good idea to have a few providers in order to check the information between the different providers and be sure that the transaction has really passed and the data is not corrupted. And once the event is catched and the information is verified, then the minter is minting GSO back to the user's address, but this time on the ICP part inside the plug wallet. So this is the deposit flow. And the other flow is if the user is already holding some GSO, he could either mint it, or he can use some DeFi protocol on top of ICP and receive this GSO token. Then he can decide to basically convert his GSO token back to the original Solana token. So the user can click withdraw, and he will send the transaction to the GSO ledger and basically burn their GSO tokens. Once this is done, the GSO ledger will sign a transaction with some paywall, and then the treasury program is already knowing what is the public key of the GSO ledger, basically the public key, which is controlled by the GSO ledger. So the treasury program can verify the signature against this public key, and if everything is correct, it means that the signature is provided from the correct ledger and everything is like correct. Then the Solana tokens are unlocked from the treasury program, and they go back to the user's Solana address on the Phantom wallet, for example. So this whole flow is basically depending on the HTTP outcalls and the signatures that I mentioned. And now you can think, how can we scale that? On the next slide, we can go one step further, and you can see what will happen if, for example, we have the Solana network and the Cardano network, and we want to have the same ideas. So, for example, we have some user who wants to deposit ADA and receive ADA tokens on the ICP network. So what the user can do, for example, this is Bob. Bob can send some ADA into the Cardano treasury program, which is a smart contract. Once the event is detected from the minter contract, then the minter can mint some other tokens back to the Bob's address. We can do this. We can use the same minter who is also fetching events for the Solana network, but this time Alice can deposit Solana tokens into the Solana treasury program. And once the events are detected from this exact Solana treasury program, then the minter can mint these Solana tokens back to Alice's ICP address and it will mint some GSO tokens. So you can see that with one minter, which is connected to multiple RPC providers. It is configured to listen to multiple events. We can have a bridge which is working for multiple chains. It could also work without problems for ETH, for Bitcoin, and maybe even some networks that are not EVM compatible and have some more specific signature schemes, because when it's time to make the withdrawal, what is happening, for example, whether we're burning GSO or we're burning ADA tokens, we're providing a signature. For example, if you burn GSO, we're providing a signature, sending the signature to the treasury program with some paywall. Then the data is parsed, the signature is verified. Again, it is just an ECDSA signature, and we're using a function similar to ECRecover. And if everything is fine, the GSO tokens are unlocked back to Alice. And same for the ADA token. We can provide a signature. The treasury program in Cardano can verify the signature, and the tokens are unlocked. And we can have many other chains using the same exact logic. We just need to add new listeners and event parsers. But the signature is the same, the minting is the same, the burning is the same. Basically, these two contracts can scale up to tens of networks. And these networks don't necessarily need to support ECDSA signature for key generation, but they should support some kind of ECRecover function to verify the signature. But from my understanding, most of the chains are supporting it. This is what I wanted to share. I think it's a scalable way to create a multi-chain bridge and plug in multiple networks without the need to support all their key derivation signatures. You can see here some useful links. We already have a working instance of this protocol, which we're calling Galactic Bridge. And it is supporting basically minting tokens from Solana and converting it into GSO on ICP and burning the GSO and getting back your Solana tokens, which is at the moment not supported with the CK Solana because at the moment ICP is not supporting the ECDSA signature, but that way with this workaround we can support it. So I hope that it is like a good inspiring idea and we can see more protocols and bridges built on top of that. So inside the chat, I will also share my I will also share a link to the presentation, so you can go and check it, and you can also check the useful links there. There is a GitHub repository that is for the Solana part. There is a GitHub repository for the ICP part, and using similar logic, you can implement it for other chains. Yeah, thank you.
Awesome. Do we have any questions for Tito? I see there's already one question in the questions tab, but is there any difference between a CK token and a G token?
There is no difference. It is just a naming convention. And as far as I know, CK tokens are like special for the Definity Foundation. Basically, everything which is starting with CK is some development of the foundation, and they put their name after it, and they put the audit and all the checks. And that's why we decided to name it GSO, because it is not officially developed by the foundation, but by our team. And the token is called GSO, and our bridge is called Galactic Bridge. So G is coming from Galactic. So all the tokens that you see starting with G, at least for now, are coming from our bridge. Yeah.
Cool. Awesome. Do we have any other questions? Feel free to post them in the chat or in the questions tab. Until then, I'll ask a question which I ask everybody else. Where can people reach you, Tito, on the social networks? I assume you have a Twitter account or something of the sort.
Yeah, I think the best way is to reach me on Twitter. I can share here my Twitter link if it's fine. And yeah, that's the most convenient way for me.
Cool. All right.
Okay, I've shared it in the chat.
Perfect. Two more questions. Okay, three more questions. Let's take one at a time. First of all, besides the immediate need, why would I choose over Galactic? Why would I choose Galactic or just waiting for NNS supported CK tokens?
I mean, you can wait for the support of the CK tokens, but I don't think that the foundation is going to support all possible networks. At the moment, there is no other alternative for Solana, and we are planning to integrate other networks. So yeah, I think that the more options you have, the better. Like we know there are multiple stable coins, it's not only one. So it's your choice which to use and which is available when and where. So yeah, that's what I can say. I'm not saying which is bad or which is worse or which is better. It's just different options and different business logic.
Yeah, that makes complete sense. Next up, L is asking, is all this being used in production? And if so, where?
Yeah, if you check the presentation, you can find the link. It is inside the presentation. So yeah.
Cool.
It is still early beta. I think, I mean, I've transferred like 20 Solana tokens and it is working fine. It's still under development, but yeah, you can go and check it with some small amounts.
Amazing. The next question is from Pedro, who's asking, is Galactic Bridge available as a managed service?
Yeah, we can do that. I mean, you can contact me on Twitter and we can spin off like a white label solution for you and you can use it for your own purposes.
Cool, amazing. Then another question from Matthias. Thank you for the questions, Matthias. They're awesome. Any estimate on support for ED 25519?
I mean, isn't this, I think that we're supporting KD 25519. When I'm using tECDSA, I think it is a synonym of the same encryption scheme. So basically the same thing said with different words.
Cool. All right. Any final questions from anybody else? Let's give it a couple of more seconds. There we go. One more question just popped up. Any plans on supporting Circle's CCTP?
I'm not sure what is Circle CCTP. If you can elaborate
They're
on
mainly
that.
interested in like a GUSDC variant.
Okay, this is on, I mean, this is the Ethereum 1 USDC that you're asking for.
Yeah, I assume so. They're asking CCTP is the cross-chain transfer protocol. That's what they're
Okay.
referring
Yeah,
to.
I mean, basically we can do it without a problem. The hard part, to be honest, is market making and liquidity. From technical point of view, we can do it in a few weeks, but we need to see that there is demand and people are using it, and to think of some incentive scheme in order to provide the liquidity into this protocol.
Okay. I think I see Matthias typing something, so let's give him a sec.
Yep.
If you have GSOC, could you bring liquidity from Solana into ICP via such GUSDC tokens? That's just an idea that he's suggesting. Do you have any opinion on that?
I mean, you can do it. We just need someone to put the GUSDT. I mean, I personally can put a few thousand K or whatever, but in order to make it a really viable protocol, we need hundreds of K into this protocol, because after that it should go to the exchanges on ICP, it should go to the AMM applications and lending protocols and so on. So in order to be widely used, it needs to have a critical mass of liquidity into it.
Cool. Amazing. I think that just about brings us to the end of the first session for today. Thank you very much, Tito. Any final words for our listeners?
I just want to say thank you for the questions, for being here, for your attention. And if you have any other questions, ideas about the bridge, you can reach me on Twitter and I'll be happy to discuss it with you.
Awesome. Well, thank you for coming in and thank you for the wonderful presentation and for answering all of the questions.
Thank
Then
you.
we'll see you some other time, and bye.